So let me hit record. So as I was saying, the book likes to break things apart into three different sort of sections or techniques for solving these problems. So understand, solve, and explain is how they break it up. So understand that they're talking about reading the problem, understanding the problem. Solving, they're talking about writing out an equation, writing out your variables or your equation. Variables, if you have variables. I don't think we're going to have variables here. But solving is the equation, writing out the equation, solving it. And then explaining after you do the actual physical math, you have to go back and look at the words and see what they are talking about. So here we're starting out with this problem. This first problem says, how many buses are needed? We want to transport 495 people, and each bus holds 45 people. So they're asking how many buses will we need? So here and in this section, I'm going to be really sort of particular about units. So you should give me a number. What is this full question view? They changed this up. Oh, look at that. This is a little smaller. Okay. How do I get on? Oh, there's an X right here. There's too many screens on my screen. This is the participants view, response view, full questions view. There you go. That's nice. How many buses are needed to transport 495 people? So you should have a number here. You should also have a space and a word. What is the unit on this thing?
Would it be
And
buses?
as I was saying, you probably don't have to do unit analysis on this, but you can, and it will show you that you're doing it correctly. All right, so this should not take too long. Here's like one little thing you got to do here. I'll give you all like half a minute. So the quick sort of thing is we are dividing people up, right? We have 495 people. We are dividing them into buses that hold 45. So hopefully we get that this is a division problem. So it should be 11 buses. So what are y'all saying? Yes, you're dividing it, but I want a response. So that would be part of the explain part. So you got to explain it. You have to tell me the number. You have to tell me the unit. So it should be 11 buses. Someone say something like really similar and it just 11 each. Oh, okay. Yeah, that's fair. It should really be buses. And so a little bit about this. We have unit analysis. If we're looking here, how many buses? You probably don't need to do unit analysis on this problem. It's way easier than than a lot of sort of problems out there. But if we wanted to do unit analysis and we're multiplying, and I talked a little bit about this, how can I simplify the units in this thing? So if I have 495 people, if I have people here and buses to people here, which of these units would simplify out?
The people would cancel out.
Can you talk a little bit louder?
Out. The people would cancel out.
Yeah, you can simplify out people up here. with like people down here, and then look right here, we're left with buses on top. So we want the units to be on top is another thing. If they're on bottom, we might have to flip some numbers. It's not a big deal, but we could do it. And so this should give us something with buses in it. So I do it later, but I like, you don't even have to know. You don't even really have to know how to set up a problem. You just like, you can plug in information that they give you. Let's stop annotating this. Here we go. Next slide. Oh man, I gotta clean my annotations off, don't I? All right, clear all the things. Exactly. And I did a bit later. You don't have to know like how to set things up correctly. If you do your unit analysis, it will tell you how to set things up, sort of. Okay, so this one, I think we're doing what, area and volume of a garden. Is that what it is? A raised flower bed. So this one, we want to find two different things. I broke it up into two different questions. But the first question they ask is to find the area of the bed. So they tell us a raised flower bed is 30 feet by 6 feet by 1.2 feet deep. So 30 feet long by 6 feet wide by 1.2 feet deep. What is the area? So what they're talking about is like looking, aerial view, right? Looking down on it. So how do we find area? It is what times what? And then the other thing here is it's going to be really particular about your units. So the first thing we're going to do is we're going to find area. And then the next question that's coming up right after this is to find the volume of that bed. Find out how much mulch we can put in that bed, I think is what it's going to say, something along those lines. So you should give me a number. You should give me a unit. And the thing about the unit, I try to put it in as many different ways as I can. But you should be able to use the caret symbol if you need to use the caret symbol to denote the exponents for caret symbols. And I think I try to put it in the whole word, and I think I try to put it in abbreviations. I think you should be safe if you do it right. Hopefully. All right, so this should take you like, I'll give you 30 more seconds, but this is, we've gone over what area is, we've gone over what volume is. So the number that I'm looking for should be what? 6 times 30 should be 180. And if I have 30 feet by 6 feet, if I am doing feet by feet, look at y'all writing out that word. Why did mine not get counted correct? That's weird. It should be feet squared. So I think he left out a T there, probably typo. It should be 180, not cube feet. This is the area. So the area is just the width and the length. So this is kind of like we're looking at it from a helicopter or from an aerial view. We're just looking at how wide, how long. The depth is going to come in. Well, I can't give you really too much. Yes, this is exactly it. Give me the solution though. I mean, I expect work in your when you submit work, right? But on like these things, if you want it to see if it's going to count it correct. Feet squared, that's all right. It should really be square feet is what we typically say. So feet. I don't know why I didn't count my feet right. All right, so y'all are getting the next question, I think, right, is what some of y'all are answering and why it's not counting it. It looks like y'all are getting it correct. It looks like it's just not counting it correct on a lot of y'all. Which is okay. I still like this because I can still see what y'all are doing. So now we're doing the volume one. So this one, it should take you like hopefully 30 seconds more. We just did the area. There's like one extra little thing you got to do with the volume. And now instead of multiplying 2 feet, now we're multiplying 1, 2 feet together. All right, so I'm going to hit next. So I believe if we multiply 180 by 1.2, I believe is what it is, we should get something like 216. I think some people were answering that last questions already. And 216 in, let's see, it should be cubic feet now. So now we're going up 1 more feet to cubic feet. So I think some people left off their units. I see one that said square feet. Oh man, this should take you a few seconds. I don't know. Identifying the units of the following quantities. State the units mathematically, for example, miles per hour. In words. State the units mathematically and in words, for example, miles per hour. So they want to know what the units on this problem would be. So if your average speed on a bike ride, they're talking about your average speed on a bike ride found by dividing distance traveled in miles by the elapsed time in hours. Oh man, I think it's too early for me to know how to read or something this morning. Oh man, did I put that? Oh man. Okay, so it says kind of like right here, right? We're dividing this by this. So what is the units when you divide that by that? And I'll give you like 30 seconds. This is not supposed to be anything like super hard. I hope I put in every like sort of response because there's a few ways you can tell me these units if I'm being honest, right? I think I missed one, to be honest, and that's why I typed it in. I'm probably gonna get a womp womp. All right, so I think that is pretty much it. If we divide miles and we divide miles by hours, I should have put MPH in there, right? Usually you see this thing abbreviated as mph. Miles per hour is good. What did y'all tell me? Miles per hour. mph is all right. Miles per hour. That's good. You just wrote it 2 separate ways, so it didn't count it. Miles. This needs to have some sort of division in here. So, GME, don't know what that is. Hours per mile. It should be miles per hour. And this is one of those sorts of things we could do this with unit analysis too if we wanted to. We have 2.5 ounces. We have 1,200 per ounce. How would you figure out how much money that's going to cost you? And remember to put your commas in things if you have a number. So if you got a number that's in the thousands, remember to put a number, remember to put the unit. Okay. So I feel like this is like one of the more sort of common things that sort of happens. Like if I go to the store and buy, 10 apples and they're 9 cents an apple. Same sort of problem, right? What am I going to do with those two numbers? You should be multiplying those two things, right? So we multiply 2.5 by 12,000. We should be getting 3,000. What are we saying? Wondering what is $3,000. Okay, so if I'm doing the dollars, usually when I do my dollar sign or do dollars in, I can't speak now, quizzes, I'm doing it with the dollar sign and not the word dollar. So it's all good. We know you know what you're talking about. You know what you're talking about. If your car gets 32 miles per gallon, how much does it cost you to drive 30 miles when gasoline costs $2.55 per gallon? I believe after this thing I have it set up, and if not, this is the one I believe. Okay, so this is the one I do it like kind of a stupid way first. In the next slide, we will go over how to do this. But if I get 32 miles per gallon, if you just write out your units and what they mean, what does that mean? 32 miles per gallon means 32 miles, and I have a division bar and I have 1 gallon. I have that ratio somewhere in there. And if you just write out your units, and if you write out things so that they cancel out, you should be getting a correct solution. You might have to flip things if you mess things up. But as long as you pay attention to your units and get things to simplify out, that's kind of our strategy, is to get things to simplify out, get things to cancel. And we will have a few things that are kind of like this. We do have another problem coming up, I know. That's got miles per gallons and dollars per gallon in the gas. It gives you gas mileage and number of miles and the cost per gallon. So this is one of those things we got to get down somehow. The unit analysis and simplifying out units. It will make your life easier in this class. It will make your life easier in so many other classes. And I remember this, like, it's one of those things that usually takes people a minute. It took me a minute to get down. All right, I'll give you a few more seconds. All right, so what are the odds I answered it right? Hopefully I got it right. Okay, that's 239. What are y'all getting? 230, 272. That's a little high. It should be under 255 for sure. So a few people look like they might be getting it. All right, so let's go over. If I had no idea how to do this, and I talked a little bit about this, but I could start out just going with the order that things are in this problem. This is the I have no idea way. So if you just start out and you just start out with the things that are in the problem, I talked about this. This is 32 miles per gallon is what I'm trying to say here. If it doesn't give you a number out here, like just per gallon, this means per 1 gallon. So does it go? Next bullet, come on. Just write what they're giving you in the problem. So this is not going to be in the correct order. There's going to be a little adjustment I have to do in the end, but it will still get me the correct answer. I just have to like fix things up a little bit. The next thing I know, I have 30 miles. And so if I'm looking here, if there's 32 miles on top and there is a gallons on bottom, if miles are on top and gallons are on bottom, where am I going to have to multiply by miles to get rid of these miles? Am I going to put the miles on top or bottom? This may not be the way you did it, but
Could you repeat that?
if miles is on top here, where does miles have to go over here if I'm multiplying it and want to get rid of miles?
At the denominator?
Yeah, it would have to go on the bottom. So this is kind of the stupid part, and I didn't set it up right. So usually you do 30 over 1, and what this is indicating is that I might have to flip things in the end. So you probably really shouldn't put things over 1 just willy-nilly. But like, just assuming you mess this thing up, this is your solution, except I just got to flip it, right? I got 30 times 2.55, and I divide by 32. And if I do a little bit of annotating here, my miles is simplifying with my miles here. And I set this thing up so that my gallons would simplify with my gallons. I'm ending up with my dollars on bottom, which indicates I just messed up and I got to flip things. All right, so maybe the more proper way to do this, I have that on the next slide is where I'm going with this. Exit on annotations. And so usually what you do is you start with what you know. I know I have to drive 30 miles. These like something per something, something per something. I know those are going to be conversions from one thing to another when they say the word per. And so the thing that is like a good even sort of units here is this 30 miles. So if you start with what you know, I got to drive 30 miles. First thing I'm looking at is simplifying out miles. So the only thing I see that has miles in it is this thing. So I know this isn't a fraction, but if I want, I can always put whole numbers over the number 1. So this is sort of like miles is on top. So if I want to simplify out miles on top, and we did it last time, I got to put out miles on bottom. So I know I'm getting 32 miles per 1 gallon. So this would probably be the more sort of correct way that things get set up. So that my miles simplify out of my miles here. And I know my gallons simplify out of my gallons here. I end up with something that is dollars on top. And so I multiply through on top, I multiply through on bottom, I divide the top by the bottom, and I have my solution. All right, so are there any questions? I think like the main takeaway and the main approach to this unit analysis is that if I have one on top, I have to have one on bottom to simplify it out. If I have one on top, I want to put the other guy on bottom to simplify it out, and vice versa, right? If it's on bottom, I want to put it on top. Okay, so let's clear this and go to the next slide. Slide to the right. All right, so what is this asking? Oh, this is a student solution. Is the student correct? Consider the following exam questions and student solutions. Determine whether each solution is correct. If it is not correct, write a note to the student explaining why it is wrong and give a correct solution. So the exam question, this question the student answered was a candy store sells chocolate for $7.70 per pound. So this question, if those words didn't make sense, you're pretending like you're a teacher basically, and you're saying whether or not the student's right. So this is the question they're answering: is a candy store sells chocolate for $7.70 a pound. The piece you want to buy weighs 0.11 pounds, and how much will it cost to the nearest cent? And so the student said, well, I divide 0.1 by 770, and I get a number I can't see because my little bar is in the way. Hold on, let me move this. 0.014. So are they correct in saying that we're dividing these two numbers? If you want to do unit analysis on this, you can.
Wait, so do we?
But is this the correct way to get it? So if chocolate sells for $7.70 per pound, you might want to just like think about this question without looking at their response. How would you figure out this? Because I'll give you a hint, they're not right. But I want to know why they're not right. What should you do with these two numbers? They're giving you $7.70 per pound, and they're giving you 0.11 pounds is how much you're buying. This goes back to the apples, right? I'm getting 10 apples and they're 9 cents an apple. What am I doing with those two numbers? They gave an answer in dollars. It's just in cents. Right. Yeah, the answer is in what? That's dollars. It'll cost 0.14. So what are they doing? Price divided by the quantity is higher. I don't. Okay, so I think some people are getting this, but if I'm getting 10 apples and they're 9 cents an apple, how much is that going to cost me? Multiplication, right? You do 10 times 9 cents is going to give you 90 cents. And so it should be closer. Yeah, I think you're getting it right, like 85 cents or something like that. All right, I think I'm one of those people that didn't answer. I think I have it on the next slide, right? You should be multiplying those two numbers, not dividing. And we can do this with the units. If this is what, 11 cents, or no, 0.11 pounds, and this is $70 per pound. Our pounds would simplify out, being on top here and being on bottom over here, and we'd be left with something in dollars. But I feel like this goes back to that apples example, right? If we're getting what, 10 apples at 9 cents an apple, we're going to multiply those two things. We multiply the rate, the cost rate, by the number that we get. Okay, so now we're doing an air conditioning system can circulate 350 cubic feet of air per minute. Ooh, now we're doing conversions in multiple dimensions. So we talked a little bit about this back when we did geometry. But remember, 1 yard is 3 feet. So if 1 yard is 3 feet, we got to think about square feet, and we got to think about cubic feet and how those differ. So if my conversion factor is what, 1 yard to 3 feet, what is 1 square yard? How many square feet is 1 square yard? Should be 2 decimal places. Oh man, y'all are rounding it to the nearest decimal place. 2 decimal places is what it says. 6. All right, so I think some people are getting this. But if 1 yard is 3 feet, 1 cubic yard is if one yard is 3 feet, 1 square yard is what, 9 or 3 squared feet. And if we go to cubic, we have to cube 3. So 3 times 3 times 3 should give us 27. So the factor here, what we're looking for is 27. We should be dividing 350 cubic feet by 20. Ooh, wait. I think I have this like spelled out too in the next slide, to be honest, now that I remember it. Oh, I didn't hit submit. But it should be 12.96 is what you should be getting. And it should be cubic yards is where we're going. So I saw a few people had the right sort of thing and they just rounded to the wrong sort of spot or something. I think the book just rounds to the nearest whole number. Okay, so this is what I was talking about. If you want to see this written out, if I want to talk about cubic feet, that means there are 3 feet there that are getting multiplied. So if it helps you to write this thing out 3 different times for cubic feet, that is fine. And what a lot of people do is they'll think about this. 1 yard is 3 feet. That's all good and well. But you got 2 more feet walking away right there, right? It doesn't get all of them. So I have to do this 3 separate times. Or I'm going to take 350 and I'm going to divide it by 3 times 3 times 3, which will give me 27 that I'm talking about. So this is how I go from, and if we mark out our units, we can see, right? This feet is going to take that feet to a yard. This feet is going to take this feet to a yard. Each one of these is going to get rid of a feet and replace it with the yard. In the end, I'm going to have yard times yard times yard. That's where I'm getting my cubic yards from. Questions about anything? Have y'all done unit analysis before? Is this new? Is it old? Somewhere in between? Don't know. Didn't pay attention. It's a bit new. Okay. Yeah, I remember like getting introduced to this stuff definitely like towards the end of high school, beginning of college. So I remember like right around y'all's age probably. And it takes you practice to get used to it. Like I said, you can be as lazy as you want in this class, but like you're kind of dooming yourself, you know. I really encourage you to follow along and try to get this stuff done ahead of time. Try to do it before I do it. Stay one step ahead. All right. Your dinner in London cost 82 British pounds. How much was it in US dollars? So when I have the dollar sign, or when I have dollars, US dollars, in my answer, I just use the dollar sign. So this one, I believe, should have a dollar sign since we're talking about US dollars. There are basically 2 different ways to get this number. If I do, okay. So one thing you do have to know is how to read this table, I guess, right? So this is dollars per foreign. This would be foreign per dollar. So you got to figure out which one of these it's talking about. But if we're going, let's go to euros. So this says dollars per foreign. This means there would be 1.058 American dollars, and we would divide by euros. This would be the other way around. So this would be 0.9449 and we'd get euros. And this would be divided by dollars. So these are kind of flipped and I talk about it in the notes. But they're reciprocals of each other, right? And this goes back to the fact that if I divide by 2, it's the same thing as multiplying by a half sort of thing. So I think what I'm saying is you should either be dividing or multiplying by one of those numbers. And there's two sorts of ways to do it. Multiplying by one is the same as dividing by the other. They are the same conversion factor, just written a little differently. Yeah, and then I know like this is something you could probably type into Google, right? And you probably do want to like you probably do want to Google your like current currency exchange rate and not something from a table that's three years ago in your math book or something, right? But with that said, you may or may not have internet access, right? And so you might have to do something like this by hand. I don't know what to tell you. Let's say 100.12. Or the other people close and just no, I think you want the other way. Yes, I think you might have went the other way, or maybe you selected something. Let's look at this. So, I think I have this broken down on the next slide, actually. Let's look at the next slide. Yeah, there we go. So your dinner cost 82 British pounds. How much was it in US dollars? So I hope you're either using this 1.221 number or the 0.8191. So it should be from this row that says British pounds. We are dealing with British pounds in this problem. So you can use one or the other. If you do this one is dollars per foreign. So I think this is the next one I got up on here. Dollars per foreign means there's $1.221 per pound. And this goes back to the unit analysis, right? I want to know whether I'm putting this on top or bottom, how this thing goes. And so I want to set this up so that my pounds will simplify out with my pounds. So those are the two things you're trying to get to simplify out. The other way around, if I use this 0.8191, this means 0.8191 pounds per dollar. So that would indicate that 0.8191, which is my pounds, and if I'm starting with 82 pounds, I want my pounds to go away. So whether I multiply by 1.221 or whether I divide by 0.8191, I should be getting around the same number, which I believe is $100.12. That's what the solution was. And then the other thing that you might want to take away is I got my dollars and they're staying on top. So if they were on bottom, I might have to flip things around or something, right? Any questions on this, how to do currency conversions? And from my understanding, the currency conversions is something you do want to check too, because a lot of those sort of like tourist traps, ATM places, from my understanding, depending what country you're in, they may or may not give you the current currency exchange rate. A lot of them, I think, are tourist traps. A lot of those ATM machines, they're not really legitimate banks. I don't think is what they are. All right, so now we are doing it is like one step more. Now we have something in euros per liter. We want it in dollars per gallon. So the first thing I hope you're looking at is we are doing euros. So you're either using this 1.058 number or you're using this 0.9449, one way or the other. So I might even like, if this is freaking you out, you can put this per what? €1? Euro. And this would be the euros per dollar, right? Euro. For every $1. So whichever one, you can use either one. It might throw you off by like a cent, one way or the other, but it'll be pretty close. So first we want to convert what? Euros to dollars. Then the next thing, and personally I would do this all in one step. The next thing we want to do is convert liters to gallons. And this one, so before this one, if I'm being honest, before this one, I really feel like you could have done them without doing unit analysis. A lot of these problems, you could probably memorize some sort of little gimmick, little trick, probably figure it out. This one is going to be a bit harder to do without doing unit analysis. And I got it broken down on the next page. So I'm not just going to leave it completely by yourself. But it is important that you try these things out. Try something, even if it's wrong. I will be happy if you answer something that's wrong. I will probably be even more happy because there's probably 10 people thinking it, and nobody wants to admit it. That's usually the way things go. Euros to 1 liter. And what is this thing again? Let me look back. 0.058 dollars for every it might even be beneficial just to think about your units without looking at the numbers, right? Without looking at the conversion factors. Because we kind of know like what units we're going to go from, right? We're going to go from euros to dollars. So I know euros is what on top here. So that already tells me that like the organization of my first fraction, what I'm multiplying by. I'm putting euros here, I'm putting dollars there. To get rid of euros and to go to dollars. The next thing I'm going from what liters to gallons. My liters is on bottom here, which is a little bit different from what we've had previously, maybe. But without even knowing like the numbers, right? You should be able to sort of get like the organization of it set up. And then you can go plug in your numbers. You can look at the table and figure out what the conversion factors are kind of after the fact. Did I do this right? 5 liters per gallon. 1.058 milliliters per gallon. I hope I did this right. And then the other thing that might be a little bit tricky on this is the units. So don't forget your units. Round it to 2 decimal places. It's a money amount, so you should definitely be rounding it to 2 decimal places. Where are we at? One person. I believe I got this broken down in the next one too. So 693 is a little bit high. 6 is pretty close. It should be around $6. It should be 601 if you round it up. 601. You should really say the word 601 per gallon. There should be something that indicates division. 601 per gallon. It should be like either a division bar or the word per. So it seems like we're hitting all around it for the most part. There's a few people a little off, but do you want it to proceed? Yes. It looks like maybe you multiplied 2 of those things and divided by the other one. I believe we're multiplying all the way through on this one. 601. Okay, so a lot of people are getting that right, even though it's not going to count it right. Let's look at the next slide. I believe it's got it broken down. But this is sort of like I'm saying, if we start out with 1.5 euros per liter. I think I got this all on one slide. But just looking here, ignore this part. So just looking here at 1.5 euros per liter. I know the first thing I want to simplify out here is euros. So without even knowing any numbers, if euros is on top here, I know euros has to be on bottom here. So the first thing I want to do is go from euros to dollars. So this is going to take care of these euros. It's going to leave me with something with dollars on top. The other thing I want to fix here is this thing called liters. I know my liters is on bottom here. So if I want to get rid of it, I got to swap it. So liters here has to go with liters on top here. And I'm going from liters to gallon. If I look at this, my top is in dollars, my bottom is in gallons. This is in dollars per gallon like they asked. We're taking dollars, dividing by gallons, that's dollars per gallon. Okay. Any questions about this unit analysis stuff? Do you understand the operation, right? This is just multiplying through on top, multiplying through on bottom. We multiply everything through on top. Basically, we're just multiplying these 3 numbers. It's nothing but ones on bottom. Okay. I think there's one. Is there 2 more? Or is there 1 more problem? I think there's 1 more problem, but there might be 2 more. I think there's 1 more problem that's got 2 parts. actually got 4 parts. Yeah, that's what it is. So we are on the last problem. We're almost there. Suppose your car averages 38 miles per gallon on the highway if you're driving 55 miles per hour. And then it's going to average 32 miles per gallon if you drive 70. So you're going to get different mileage depending on how fast you drive. That's basically what this is saying. You drive slower, you're going to get a little bit better mileage. You drive faster, you're going to get a little worse mileage. Kind of to be expected. So now what are they saying? They're saying, what is the driving time if we take a 2,000 mile trip and we drive at 55 miles per hour? So this is the first question I want to ask. The next question that we're going to answer is, what is the driving time at 70 miles per hour? So remember, this is a section about units. You should give me a number. You should give me a unit. And I want to say I rounded everything to 2 decimal places. So what is the time in this? It might help you with your unit analysis to do unit analysis. It will tell you what units you'll be in. So they want to know time, and they're giving us speed in miles per hour. So how long is it going to take to drive a 2,000 mile trip driving 55 miles per hour? And I'll give you a hint, you don't need all this setup. Basically, you need just like this information right here. 2,000 mile trip and you're driving 55 miles per hour. How long is that going to take you? You have your distance and you have your rate. You should be able to find your time from that. Oh, man.
Wait, so for now, do we just answer the part that's highlighted?
Yeah, just the green part, just that first question. What is the driving time for a 2,000 mile trip if you drive 55 miles per hour? Make my algebra class do like a lot of these things. Like if I leave 1 hour after you do, and I'm traveling 55, you're traveling 55, and I'm traveling 70, how long will it take before we meet up? Oh, man. Those rate problems in algebra, we do a lot of those in algebra. Those have variables in them. This one is a little more straightforward. I think if you do your unit analysis, we want to end up with something that's in time. We know we're going 2,000 miles, and we know we're going 55 miles per hour. All right, so I'm going to show you how to do this one on the next slide, and then we're going to answer the second part, which is basically the same question, but we throw a different number in there. So I hope most of you are getting something close. Let's go over it, and then we'll go over that other thing. So I hope most of you get it pretty close on this one, and hopefully everyone gets it on the next one. So if we want to look, this should be 36.36 hours. 36.36 repeating, I think is what it was. Yeah, you got the correct things, didn't round it to the right place. Yeah, you should. Okay, so another thing, and I see it, but you should put a spacing between the number and the units. And I know that's one of those things only the computer's going to count incorrect or whatever, but for what it's worth, right? So this is what I'm talking about, unit analysis. So if I'm starting out with 2,000 miles, one of the things you might need to like kind of get in your brain, right, is that if I have something that is a whole unit, like 2,000 miles, and it's not a fraction, I can always make it a fraction. So I can always make things a fraction by putting them over 1. Dividing things by 1 doesn't change it. We're safe there. I look at 2,000 miles. I want to get rid of my miles. So if my miles is on top here, my miles has to be on bottom here. So I know miles here with miles here. This thing tells me 55 miles per means my division bar hour. And if I do this, this should give me a solution that is in, maybe I got to pluralize it, but there you go. It's in hours, right? And this thing tells me I multiply through. What I'm going to end up doing is I'm going to end up dividing what, 2,000 by 55. So this is the setup if we want to find out how much time it's going to take to travel 2,000 miles, traveling at 55 miles for every 1 hour. Now, hopefully we're all getting this next one correct now. How long is it going to take traveling 70 miles per hour? It should look really similar to that thing we just did. And I should probably clear my drawing. There we go. Not too quick now. Don't forget your units. Oh man. Oh, whew. Oh, the week's almost over, ain't it? We barely even began it. It's been a crazy, crazy week, huh? It started out really fun, was the crazy part. I feel like it's like, yeah, there's snow in Texas. And it just like it was just like that. It wouldn't have been so bad, but everything just kept coming and like constantly changing. It's just like had to keep adapting. It went from like a static, there's snow everywhere, to like powers off, and it's like, oh shit, gotta like start getting things organized. Things are gonna go south really quick if I don't start taking some preventive measures. So what we should have done here is take the 2,000 and we're dividing it by the 70. And the last one we divided it by 55. The units are exactly the same. Now we're swapping out 55 for 70 miles per hour. It should give us somewhere around 28. What are y'all doing? 79 mil? What? No, we're in hours here. No, it should be miles per hour. Or hours, sorry. Okay, so I'm not sure where y'all are at doing that. Okay, so that is the time it takes. So it is obviously going to take you more time going slower, I think is what we figured out. It was like 36 versus 28, right? Something like that. Now, we got a little bit of a different question. Assume the price is $2.55 per gallon. What is the gasoline cost for a 2,000 mile trip if you drive an average speed of 55 miles per hour? So there is a lot of information in this one, I feel like. Then we're going to answer after we say what is the average, what is the gas cost if you drive at 55 miles per hour? The next line is going to be what is the gas cost if you drive 70 miles per hour? But first, we're going to answer the 55 miles per hour. So we're doing 2,000 mile trip. I'll give you a hint. You need that piece. You need this money that converts the gallons that you're driving to dollars. Now I think we need to go from what? Miles to gallons. So this is where you might have to read this first part. And I give you a hint. We don't need that part. We need this part, right? If we're driving at 55 miles per hour, we get 38 miles per gallon. So I'll give you a little bit more of a hint, I think. We're going to use this 38 miles per gallon. Can I do this? If I shift and no, it like highlights all of it, huh? Or is it control that you do? Shift control? Is there a way to highlight the annotate? That's what I could do. That would do it. So I'll give you a hint. We're not actually using the speed. We use the speed to get to the gas mileage. We use it as a kind of sort of middle guy. We should be able to do it from these three numbers, I think, are the three numbers that we're really focusing on. All right, let me try. And I think I have it broken down and I got another slide. Maybe, maybe not. Let's see. Yeah, I think I got this broken down. And the next problem, right, is very, very similar, except we change out one thing for one thing. So this is hopefully some good practice with getting these unit analysis things. So we know we're going 2,000 miles. No, we're doing that many per that many. And oh man, these get easier when you're doing for like 12 years. Like when you've been doing them for a couple decades, they definitely get a little easier. Where we at? All right, looks like most people are answering something. And you got this set up on the next page. So let's see where we're at. It should be a dollar amount. I believe you should be getting something like 134.21. Is that what I got? I think that's what I got. If you're within a few cents, it's fine, right? 134.21 dollars. So you wrote the word dollars. So it seems like a few people are getting the 134.21. That seems a little bit high. 34.21. Seems like a few people are off. So how are we getting this thing? So let's go over it. Assume you have 255. Okay, so I deleted some of the information. So what we really need is this 38 miles per gallon. We need 255 per gallon, and we start out with what we know. So I'm going to start out with the 2,000 mile trip. I start out with the 2,000 mile trip. The first thing that I see here, this first factor, I know I get 38 miles to the gallon. So I want to simplify it out so that my miles on top and my miles on here and bottom simplify out. So I set this with the miles on top and the gallons on top so that my miles will simplify out. Now this is telling me how many gallons of gas I'm using for this trip, is what this is telling me. If they ask that question, this would be what we do right here. We would ignore the rest of this. But now we want to go from gallons to how much it's going to cost us. So we know it costs us $255 for every 1 gallon. And so I want to set my gallons up here and here so that they will simplify. So this should be giving me something in dollars. So what did I say? Was it 130.21? Something like that, 132.21, 123.21. I already forgot what number it was. All right, so what's going to change when I go to 70 miles per hour? That's my question. I'm still going 2,000 miles. My gas price isn't going to change just because I go faster. That's not how gas prices work. So I think the thing that we're going to end up changing is this number right here. My question is, what am I changing it to? And that is my gas mileage. It's going to change when I go to 70 miles per hour. So hint, hint, that's what we're going to do on the next one. So let's go to the next one. Final, last problem we got to do here. We are there at the end of the class. I think instead of 38, I'm plugging in. All right, so we are changing that 38 and the previous problem to what, 32? Should be 2,000. We're multiplying by 2.55. We're dividing by 32. Now we're going 32 miles to the gallon. We are at the end of class. All right, so it should give you what, 159.38. So it looked like most getting that. What else did y'all say? 72.85. I'm not sure where that's coming from. Okay. What did you do? Like plug in 70? Is that what we all did? 70 miles per hour? Should be the 32 miles per gallon. All right, so any questions over this unit analysis stuff?
No.
All right. So we will continue talking about unit analysis. I believe 2B is where we start converting stuff from US standard to metric. So if you like memorizing odd numbers, I guess the US system is for you. I don't like it's just like one of the silliest systems. And I mentioned it, like I don't like expect you to memorize any of these conversion factors, especially the US system's so stupid. I don't know how else to say it right. It's just like it makes no sense. It's like was it 52,480 feet in a mile or something? I don't know. Ridiculous. All right. So if there are no questions, I am going to stop sharing. I'm going to stop recording.